Hello friends, welcome to Machine Learning the Future course. So in this part we'll be looking at the machine learning practicals for random forest classification. So in the last part we have seen the theoretical concept which is behind the decision tree and random forest classification. So let's begin our machine learning practicals. So for that we'll be using Spider, and let's copy this entire template and let's paste it over here, and this will be our actual decision tree, or we can say random forest classification template. And now let's look at the set of instructions, but before that let me first reset this previous one, and let me set our working directory to random forest classification, and then the action of offer, which is the same, so that will remain the same. And let's change this to random forest, and that is the thing which remains different. So let's use scikit library and a class which will be by the name ensemble library, and let's import a class which will be random forest classifier. So it will be random forest classifier. So we'll actually create object of this class which will be by the name of random forest classifier, and the arguments inside that will be the number of trees. So let's look at the number of trees, which will be, suppose we'll take it as 10. What will be the criterion? It will be based on the entropy, the splitting of the trees or splitting of the sections, which will be based on entropy, the information. And random state will be equal to 0. So I think that's it. Everything else will remain the same, and let's change this to actually decision tree, and the next part also to decision tree, and that's it. So let's execute this. So let's execute this set of instructions from here till confusion matrix. Control enter, and confusion matrix states that 8 will be the incorrect prediction number. So that is good, it's better. If you can also look at y prediction, and if you can look at the y test, and you can just compare the results over here, yes, you will see little bit of mistake over in here, because as I already stated, none of the model is 100% correct. And last but not the least, let's look at our graph. So our graph will look like this, and now this seems to be a very bad example, because this seems to be overfitting, because it's identifying the points wherever it is, and it's actually just marking it as a red region, which is actually an overfitting. But is this overfitting working for our test set? Does that thing which has been overfitted works for our test set? Let's look at that, and here's the results. So as you can see, this is the red region which was marked because of the training set results, but as you can see, the green point is observed in this red region. So this means that it's actually looking at each and every point and trying to identify the region which doesn't fits, or which doesn't actually says that it's a good model, because the any kind of new point which will arrive, it will actually fail over here, even though. So that means the number of trees which we have used, which needs to be reduced, because now it's been overfitted. So yes, we can actually reduce this, because entropy in any kind of splits should be 0. So yes, the regions over here are the predictions and the points are the truths. So all the trees have classified as predictions, and majority has been taken into the consideration. So based on this we have actually drawn this model, and this brings us to the end of random forest classification. So all those scripts and datasets are available at our GitHub account. So as we have seen various types of classification models, and we have seen the kernel SVM model, we have seen SVM, we have seen logistic regression classification model, we have seen random forest classification models, and we have seen the naive Bayes classification model. And looks like the kernel SVM was a good classifier among all those classification models. So that's my prediction. You can try from your end as well. Thank you very much. Hope you are enjoying this video series. We'll meet next time with a new module. Let's begin that module in our next part. Thank you very much. Bye bye.